Today I'm going to present static reflection today in C++17. So before we get to the library, I want to talk about what reflection is. Reflection is the ability of a program to examine, introspect, and modify its own structure. So for any of you that are familiar with the proposal, the idea is to be able to reflect a type and give you an opaque value that you can query information about the type that it reflects. In the proposal, you can reflect other things besides types, like namespaces or functions or templates, and all of those things you can query information about them. So in C++17, we can get a subset of that capability, and it looks something like this. So Metareflect takes a template parameter, in this case of either a type or a value, and it returns an unspecified object that has ADL methods in the meta namespace for querying information about the type or value. And then you can actually get other meta info objects from those. For example, on the line where you do type of the reflect null pointer, you can get the reflection of the null pointer t. And then from the meta info object, you can also retrieve the original thing that was reflected using the splice. So moving on, what does the support look like? Well, it may be a dirty, nasty hack, but it works pretty well on most compilers. So ignore the flag for GCC. We'll get to that in a second. So how does it work? Well, it uses friend injection. So let's see. We start with the index template. It takes in info as a NonType template parameter, and it defines a friend function for get, and it's a deduced return type. It's declared but not defined. Later, when we go to reflect a particular type, we get a meta ID, which is the unspecified type on line 3, and then we pass its address to the instantiation of index to provide a definition for that friend function. From the meta info object, we can retrieve the type identity, and then from that get the original type on line 24. So we can go both ways with this. We can reflect and then splice. So C++17 capabilities are somewhat limited. In C++20, with structural non-type template parameters, you can do some pretty interesting things here. I'm not going to share the meta apply implementation on here because I've only got 5 minutes, but you can check out the Godbolt link if you want to see how that works. But to explain what's going on here, you have the std_views drop, which is from the standard ranges library, and you're taking an input range. In this case, the tuple, which is a type list here, is being transformed into a range of meta info objects. We're dropping the first 2 meta info objects from that range, and then from the result, we're turning that back into the type list. So we get the last 2 types in the tuple. So this compiles. Next example, standard views reverse. We just reverse the type list. So they go back in backwards order. And then this one, we do a filter. So in this case, we use one of the ADL functions, getting the size of the type that was reflected, and then keeping the ones whose size is less than 4 bytes. So in this case, we get the tuple of int16 and int8. So the support for the C++20 is a little more limited. The reason the checkmark in Zig is orange is because Godbolt thinks there's a warning, but it just outputs something when it compiles successfully. So it should just be green. But anyway, so no non-template friend on GCC again. And all of these are C++20 instead of 17. And if you didn't notice from the previous one, they're more recent compiler versions as well. So existing efforts. Chris Jusiak has written a library that's very similar to this, BoostXMP, and it has a lot more capabilities than this one in Godbolt, but it can get data members of aggregates and so on, and then also the proposal for C++ 26 that's open right now. Thank you.